Far out. Metasploit is ridiculously powerful. Why have I not spent more time learning this? Hi friends, welcome back to the channel. I'm doing 30 seconds of ice cold showers at the end of every shower. It is wild. If you're new here, my name's Ash, I'm 27. I'm a cybersecurity enthusiast, and on this channel we do all things try hack me, capture the flags, hacking guides, Python programming, and that sort of thing. On today's video, we are going over the current Advent of Cyber 2022 challenge from tryhackme, and we're up to day 15, secure coding. For all playlists, timestamps, and links, see the description. Otherwise, let's get into the video. Alrighty, we're up to task 20, day 15, secure coding. I'm gonna hit start machine and let that VM boot up. Check out Insider PhD's walkthrough video. But first up, we have input validation. So this is one of the biggest security concerns for web apps. And it's when the web app is asking for the user to input a file, text, something into the app. And a user could be an attacker, and they can control what is interacting with a web application. So this leads to possible problems, such as SQL injection, cross-site scripting, unrestricted file upload, and others stem from this user input validation. And the task is going to focus on this and unrestricted file uploads. So like mentioned, we're going to be going through validation of file upload functionality, unrestricted file upload vulnerabilities, phishing through file uploads, and properly securing file uploads. So next up, the unrestricted file uploads. So these days, as we interact with web apps, it's just integral that we upload things to systems. We have an example here, like a profile picture for social media, like every single social media has that. So we're being able to upload something from our system, an image, to a cloud storage, or even saving like a project on GitHub. The applications for file upload features are limitless. So as mentioned earlier, when poorly handled, these file uploads can open severe vulnerabilities to the server. And if done properly, something with remote code execution, RCE, will allow an attacker to manage to upload and execute a shell on the remote system. This could lead to the attacker defacing the website, gaining further access, pivoting through a network, and who knows what else they could get access to. And as mentioned earlier, further vulnerabilities like cross-site scripting, XSS, or cross-site request forgery, CSRF. By uploading arbitrary files, an attacker could potentially use the server to host and/or serve illegal content to leak sensitive information. So typically there are two main exploitation paths. One, the attacker can retrieve the uploaded file. It could lead to code execution if the attacker uploads a file such as a web shell. Or two, if the file is viewed by a user, think of a CV application, then the attacker could embed malware in the uploaded file that would execute on the user's workstation once they view the file. So if you've gone through like the beginner path or other paths in tryhackme, you may have done some web hacking and you may have come across RCE. So they're saying that because of there's previous rooms focusing on web shells, we're going to focus on the latter exploitation path, being this one, uploading something malicious. Next section, Santa is looking for a sidekick. So going in with this room's theme, we have Santa looking to hire some new staff for the security team, who has hired a freelance developer to create a web application where potential candidates can upload their CVs. So we have a link to the latest version of this web application that we're going to be running in our VM. And we're going to look at that through either the attack box or, like I said, our local machine. So let's go boot that up. All right, VM's booted and we are on the IP address that my remote system has got here from tryhackme. So we can see Santa Sidekick 2. We've got a couple of links here, home, privacy, and we've got our heading here, CV upload for special elves. Do you think that you've got what it takes to be Santa Sidekick? Upload CV to get in touch. So we can browse and we can select upload. So if we just select upload, by default, we've got an error occurred while processing your request. Development mode. Swapping to the development environment displays detailed information. The error occurred. The development environment should be enabled for deployed applications. So we can see a handler equals upload in the URL. So just gonna sort of poke around, use this page detail. We look at the inspect, can we see anything? jQuery, Bootstrap. This could just be a custom thing that they've made. It's not like an existing CRM or anything like that, just meaning like they've put it together themselves. Okay, so as we can see, the website allows us to upload CVs, correct? So let's try use the website intended, blah, blah, blah. Using your favorite word editor, create a simple new PDF, upload it to the application. Once uploaded, we can see the following message. All right, let's go ahead and do that. So I'm just going to touch a file and just give it the extension of PDF. Then I'm just going to simply upload that file, and we've got that there. I'm just going to hit upload, and we can see this same message. CV is uploaded, send team will review. So we know from this that PDFs are accepted. So the message also tells us that there will be a human. So that's interesting to note. Let's see if we try and upload something other than a PDF. So back to the terminal, and we'll just create a file exe and repeat the process. File exe, open, upload. So there's I guess any extensions are allowed if you can upload it to exe. So that seems to work. It seems like the freelance developer has attempted to implement some security controls to prevent naughty elves. However, not all controls were implemented, but can we actually do something with this that will be malicious? Yes. So why fuss over the web root? So why would the developer take care to store the files outside of the web root? And we can see that was mentioned here in the message. Web servers are fairly simple things. You request a resource and the web server responds with the resource. The magic happens when a request resource has a specific file type. Since this is a .NET application, the following resources would be considered special: ASP, ASPX, CSHTML. When a resource is requested with one of these file types, the web server will first execute some instructions found in these web pages before sending the compiled response back to the user. Here's an example of an ASPX. So we have a form written in HTML, or we have some tags like an ID, a method, run at, and the action itself, upload.aspx. So this tells the server that the HTML element first requires some formatting before being added to the HTML in the response, as can be seen by the runat server directive. So we could upload any file that we wanted. We could upload one of these special types of pages like an ASPX web shell. If this file was stored in the web root, we could request the file from the server, forcing the server to execute the code within our file, and that's how we would get a web shell running. It would be possible to get remote code execution on the server. However, as the file is stored outside of the web root, we cannot make a request that would retrieve our file for execution. However, this protection is not sufficient for two main reasons. Other vulnerabilities, such as local file inclusion, may exist that allow us to force the web server itself to recover the file that was stored outside the web root. If the web server recovers the file, the code within the file will again be executed, allowing for RCE. And two, while we cannot perhaps get RCE using this vulnerability, we know with certainty that actual users would interact with the files that we upload. Rather than targeting the web server directly, we could target the users that would interact with these files. If we were to upload a file that had malware embedded, it would execute when the user interacted with the file, still allowing us to breach Santa's perimeter. So next section, we've got shell from Santa. So let's try to target one of Santa's elves that would be reviewing the uploaded CVs. In most cases, we would have to be quite creative with the malware that we upload, especially since this is an application to a security role. This requires us to create a CV with a malicious macro embedded. However, since we are on Santa's red team and this is a security assignment, we only need to show proof of concept. Let's use Metasploit to generate a malicious CV. So we're using MSF Venom with a -p, looking in the interpreter directory of using a reverse TCP, and we're setting the L host to ton0, or that's our IP. Listening port, we can set this to whatever we want. -f for the executable output CV username.exe. So just typing out the command, setting my listener host to my actual IP. Yeah, you want to make sure that it's your local tunneled IP. And then our L port can just be whatever. I'm just going to set 4444-F. So we're going to make it an executable. And then the output is going to be CV-username.exe. We also have the alternative using MSF console. I believe MSF Venomon is just like its own packaged program from Metasploit and the MSF console. So we're going to hit enter. So we've got no platform was selected, no arch selected, no encoder specified, outputting raw payload size, final size is saved as. So if we hit ls, we can see that that's being created. I'm not sure about the extra messages. I'm not sure if that's all good or whatnot. So we can go here and upload our CV once again. So let's go ahead and do that. Upload, and that's successful. Once uploaded, give it a few minutes and one of those elves should be reviewing it. Okay, so they've set up like some cron job on the other side to automatically open it. So let's have a netcat listener listening on port 444. Great. So it took about, I don't know, 20, 30 seconds and we've had a successful connection from some remote unknown system. So we can hit ls. Who am I? Okay, we're not getting a shell though. Okay, so it looks like the payload might not have actually worked. Hit Control C, give it another crack. Maybe it was a permission thing. We can run it with sudo. So we had the exact same output trying it again. So second time, we'll just run the listener. Okay, happen again. Still no shell. So I'm doing something wrong. Let's try the MSF console. So we'll paste that in. We've got my IP address. I can just see in the corner here, it's and set L port, and that's just 444 and exploit. I didn't realize you could just do like, oh, you didn't even need to boot MSF console, just quiet. And I guess this is like probably an execute mode. Just send the whole command through. Far out. Metasploit is ridiculously powerful. Why have I not spent more time learning this? So that took, maybe close to a minute, and we have our interpreter shell here, and we don't know who am I, but print working directory, we can ls. So we're in the system 32, so it's all the normal directories. Can we just change directories into the root? We can list out the files, and we want to see users. So let's go into the users. So we've got admin, all default, we've got a HR elf. Let's go check out HR elf. So maybe desktop, cd into the desktop, list out what have we got, ec2 feedback.website. Okay, so it's in the documents directory. We can see flag.txt, cat that out. I found you. It looks like it's this question. So let's just quickly go over the first couple questions we must have passed. So what is the file name given to file uploads that allow threat actors to upload any files that they want? I think it's unrestricted. Yeah, unrestricted file uploads allow threat actors to upload whatever they want. Next up, what is the title of the web application developed by Santa's freelancer? So we've got Santa Sidekick 2. Cases don't matter. So next, what is the value of the flag stored in the HR elves documents directory? That's where we can go and paste in the flag that we got just now. Great. So let's keep going through our content and we'll find the answers to these last 3 questions. So next up, properly securing file uploads. So to actually secure a file upload, we need to implement layers of defense. And this task, we're going to use C#. C# is a popular language used to create both Windows apps and web apps in large organizations. So let's look at our base file upload function first. Ooh, I only know Python. So looking at other languages to me is like scary. So we have some variables, full path to where something would go, a form file, and a file path combines the full path variable and the form file, the file name. So using stream IO file to passes through the file path, and then copy to async uses this stream. As I remember from Python programming, we're putting variables or objects inside other classes or objects. So let's just actually read what it says. As we can see, the developer made sure to store the CV outside the web root. So CV uploads is not in the web root, setting the full path to a different drive. However, this is not sufficient. Let's take a look at what additional controls could be implemented. So we have file content validation. We can validate the content of the file by reviewing the content type header that is sent by the browser to the file upload. So we have a string type, content type equals, right, so it's a new variable and it's going to pass through the file upload. and the content type, split it, make sure it's all lowercase. If the content type equals PDF, if it doesn't, with the exclamation mark, because that does not, allowed equals false. So if it does not equal PDF, allowed will be set to false. Allowed will be another variable, will only allow the content to get through if it's set to true. So in this file content type is not a PDF, we reject the file. While this is a good control, it will be noted that since the browser sets this header, an attacker could bypass this control by intercepting the request and changing the header. Whoa, which we have done in Burp Suite. You could get the actual web traffic request, change the PDF to like exe or something. Yeah, that's crazy. Next, file extension validation. We can also verify the file extension. So content extension equals PDF, allowed also set to false if it does not match that. This will limit the file types to only PDFs. If the user CV is in a different format, it will have to convert the CV first. This control should ideally be implemented within an allow list as shown above. Since a block list is you can still bypass it in certain cases. Then we have file size validation. Attackers can also try to upload files that are so large it consumes so much disk space that other potential candidates are not able to upload their CVs. To prevent this, we can implement file size controls. So now we have an integer variable called max file size. I don't know why it's 10 multiplied by that. Is that like 10, 20 megabytes? I'm not really sure. So, oh, here we go. We have a comment, 10 megabytes, max file size. Yeah, that's a little confusing, but sure. So if the content size is greater than the max file size, which they've set to 10 megabits. Isn't bit lower b if that's bytes? Shouldn't that be uppercase b? Anyway, if that's the case, allowed is equal to false like the others. Next up is file renaming. And as mentioned before, even though our uploads are stored outside the web root, an attacker could leverage an additional vulnerability such as file inclusion to execute the file. To counter these attempts, we can look to rename uploaded files to random names, making it almost impossible for an attacker to recover their file by name. Okay, so if you knew where it was going, like if you somehow knew it was going to the CV uploads, and you could still upload a shell, you would have to navigate to the URL of that shell to execute it. But if the name of your shell changes, you don't know what it changes to, so you wouldn't know where to exactly go to get that file. Next is malware scanning. So even with all of the above controls implemented, there's still a risk of an attacker uploading a malicious file that targets the elves that will review the CVs, as we mentioned earlier in this task. So as Santa is a high value individual, some nation states might even specialize exploits found in PDF readers to upload a malicious PDF in the hopes of getting access to remove themselves from Santa's naughty list. That's hilarious. In order to combat these types of malicious files, we can scan uploaded files for malware. Oh, that makes sense. Right? Every file gets uploaded, goes through some sort of check. So this is using a CLAM client. So it does some sort of conversion, and then there's a scan results. So it awaits for it to be synced and then sends it through, depending on that scan result, pass through the class of result from CLAM client, I assume, CLAM scan results, and there's a virus detected class. So if it is equal, so if this result is equal to a virus detected result, then again, that allowed variable is going to be set to false. Crazy. So next up, we've got putting it all together. So combining all the above techniques, we can implement a secure file upload function as shown below. So that's just all the code now put together. It's good to know. If I was a more experienced programmer doing this as a test in Python, for me, that would be a pretty good exercise. So all of these controls are required for the simple reasons that we cannot inherently trust user input. As such, user input must be validated and controlled. Sending this feedback to the freelance developer will allow them to secure file upload feature. I thought we actually had to do some coding, so I was like, gear it up, like, all right, I don't know C#, but all right, let's go. But okay, this is good. Save learning C# for another day. So back to the question, what defense technique can be implemented to ensure that specific file types can be uploaded? So this was file extension validation. So we can pop that in. Next, what defense technique can be used to make sure that the threat actor cannot recover their file again by simply using the file name? So this was file renaming. Great. And then lastly, what defense technique can be used to make sure malicious malicious files that can hurt elves are not uploaded. So malware scanning was the last one there. So that wraps up us for secure coding day 15. I appreciate you getting to this part of the video. Thank you so much for watching. I hope you enjoyed it. This was fun. It was a little bit easier than I was expecting just because we didn't actually have to do coding, but there are 2 more days of coding, so who knows, we might get a little bit more into it. Feel free to leave a like on the video. It helps me know that you're enjoying the content. It also helps with YouTube. Feel free to subscribe if you haven't, and leave a comment telling me what you enjoyed and what you're currently up to on tryhackme. On the screen, you're going to see a recommended video from my channel and the playlist to the other videos so you can catch up if you haven't seen them just yet. Thank you so much, and I will see you in the next video. Okay, I've now got to go catch up on the other days.